Hello everyone, it's the 6th of October, which means it's time for the 6th challenge from Leetcode October Challenges. Let's just go straight into it because I'm very tired and it's very late here. So insert into a binary search tree. You are given the root node of a binary search tree and the value to insert into the tree. Return the root node of the BST after the insertion. Okay, so that's interesting. So I guess this means like they're saying this because it's possible that the value that has been provided might have to be the new root node. I guess it's an edge case, but it could happen. It is guaranteed that the new value does not exist in the original BST. Yes, that's nice of them to specify. Notice that there exist multiple valid ways for the insertion. As long as the tree remains a BST after insertion, you can return any of them. Okay, so basically what's a binary search tree? I guess they have a few examples, but very quickly, this is a tree structure. So tree is like a graph, but binary tree is basically a tree that every node can have at most two child nodes, a left one and the right one. So hence the binary, it has just two possible child nodes, left and right. And a binary search tree is a data structure where for every single node, it is there are two conditions must be present. No, actually three conditions. So for every single node, the left node, if it exists, is smaller than the current node, and the right node is larger than the current node. And also, these are the first two conditions. Left is smaller, right is larger, and both left and right nodes are valid binary search trees on their own. So that's important. This means that if I have a 4 here, then there is a guarantee that all elements in the subtree that are to the left are gonna be smaller than 4. Not just the one directly to the left, but all of them. And same to the right, all elements will be larger than the 4. So if I have root 4 to 7, 1, 3, okay, that's the representation, whatever, and value 5, where does it have to go? Well, it has to be the new root. So this is how they're giving it. So it can either be the new root. So then we can have, well, we're actually doing quite a big change here just to rebalance it, right? We're adding the 5 as the new root node. And then 7 to the right, and then the 4 that was the previous root is going all the way down here. Sounds a bit easier the way that this is presented here. So I think this is the algorithm that I would initially take. So just start from the root. If the value I have is larger than the root, go to the right. If it's smaller, go to the left. Also, not just go, since the left or the right can be no. If it's no, so if it doesn't exist, I just attach it there. So like if I have here the 5, then 5 is larger than 4, so I go to the right. I have a 7, 5 is smaller than 7, 7 has no children, so I put it as a left child. And if it has a child, then I just repeat the process until I can find the spot. I wonder if this can be used to solve all the iterations. So there are some constraints that values are valid integers, that all values are unique, so they're not repeated values. And what is this? Oh, this is the input. Input is also in the same range that the values that we already have, and we're guaranteed that the val does not exist, so they're all unique. So I guess I might actually use Java for this, because I really hate how in Leetcode they code the value val, and val is actually a reserved keyword in Kotlin, so it has to be backticked, and I really hate that. I mean, I really dislike solving these kind of questions in Kotlin, and also the 3 nodes are nullable, so it just doesn't feel right to do it in Kotlin. So I'll just do the 6th one in Java. So I guess it has to be _6, right? Whatever, it will be _6. Screw you, Java. I also need this, so I need, in order to solve it, 3 nodes. So I'll have a 3 node here. Where is my definition? This is my definition. So it's just gonna be a static class 3 nodes. Wait, why didn't I choose Java here? JavaScript. Okay, there it goes. So this is the class. Well, I'll just have to remove this, and this will be a static class. So it has val, left, right, constructor, constructor with val, constructor with everything. Damn. Okay, whatever. That's fine. I don't mind it. It will just sit there. I don't care. And one more of these. Okay. So this is my solution. This is the method I need to implement. And I'll have some test cases afterwards. So what do we need to do? We're taking the root. So yeah, my algorithm is take the root. So root is my current node. Var node equals root. So if the root is null, I just insert the node there. So if I do my algorithm where I always go to the left or to the right of the given root, then unless the initial root is null, I'm actually never gonna change the root. So I'm gonna be returning always the root. If that is valid. I guess there might be a case where this is not valid, right? There might be a case where... no, there is not case. There shouldn't be such case. Because if they give me these three, like 1, 2, 3, 4, and then they cannot give me a repeating value, they promise to not give me a 3 or like any repeating value. If they give me a 0, I'll be able to put it in this tree somehow. So I think that's fine. So I'll just do something like... I'll just write some pseudocode and then I'll refactor it to look nicer. So if node is null, then I actually need to create the new node for the val. So node to insert is a new tree node from val. So if node is null, then wait, I need to actually fix the parent-child relationships as well. So I'll actually... So if the initial node is null, then I'll just return node to insert. I'll just return this. So this is in the case where my root node is null. So I can just do if root is null. I do this to make sure that I'm in a valid state. So now I have a node, and that's a valid node that has some number. And I have to do a couple of things. First, I do a comparison. So is val smaller than node.val? If it's smaller, then go left. Otherwise, go right. This is what I want to do basically. But when I say go left or go right, I actually mean peek left and peek right. So if I go left, and node dot, is it left child or just left? Okay, so node dot left is null. Then I'll just do two things. So I say node dot left equals node to insert, and I'm basically done. So I'm just gonna say return root, and I have solved the question. I can do the same for the right one. So if go right and node right is null, then I say node dot right is node to insert, and return root. I guess I can, this is common path, so I can just do it afterwards. So if I pass these conditions, then I know for a fact that both left and right are not null, and I can just recurse further down. So this should probably be a method. So that's cool. I'll just create a method. So it's gonna be a private since I'm keeping the root, I don't think I need the root here, so I'm just gonna do it as a void for starters. Insert into BST, and it just takes a 3 node and the 3 node to insert. Okay, so it takes these two, and I'll just say, if the current node, can it ever be no? It should never be no, because I'm always gonna be peaking a level down. So this node I think should never be no. So I'm just gonna presume that it's not no, and for the initial one I have it covered by this check. So what I'm gonna do is I'm going to say, I'm just gonna go with the algorithm. If node.val is smaller, is bigger than to insert.val, I'm not sure if I'll need this check, but I'll write it here and maybe I'll change it later. So if it is bigger and node.left is no. So this is my precondition 1. Then I'm just going to say node.left equals to insert, and then I'll just say return. If node val is smaller than to insert val, so if node val is bigger, this is the case here where I'm tasked to insert a 0 here, for example. So 4 is bigger than 0, and left is not no, so I basically have to continue recursing. 2 is 0 is bigger than 0 is smaller than 2, so 2 is bigger than 0, and left child is not no, so I recurse. Then 1 is bigger than 0, and 0 is 0 is so yeah, 1 is bigger than 0, and left child of 1 is no, so I insert 0 here and I return. This is what I want to do basically. So this is my edge case. This is where I insert to the left, and here I should insert to the right, the same. So node.right is no, then node right is to insert and return. And the node I'm inserting currently has no children. So this is some base cases here. This is very easy. It's gonna be a little bit harder if I have the case like I have more inputs that are more disjointed. So I need to draw an example somewhere to make sure that I don't forget to cover it. So let's say I have the node like 5. Can I just do a block comment so it's easier to write? So let's say I have a 5. I can zoom it maybe a little bit. Let's say I have a 5 here, and they might even be more. I'll just use some bigger numbers so it's easier to work with them when I'm not sure what I want to represent. So I have 5, 33, 22. This is the tree that I have. This is the binary search tree that I have right now. And I say I want to insert into that the value 44. So this is the case where I'm starting from the root. Root is 55. Well, it could have been just 532, but whatever. Root is 55. And I say, is 44 bigger or smaller? Well, 44 is smaller, so I go left. Is 44 bigger? Well, it is, so I'll put 44 here. Is this a valid bit? Well, I guess this is valid. Because I was thinking that I have to do like, I have to put it in between 33 and 55. But actually, what I just described is also a valid binary search tree. But it's possible that it could not be valid, right? Is it possible? Can I always just insert it as an edge node? Like a leaf node, I'm sorry, a one that's ends the tree, so when there is no child. So let's say I have here something like 45. So 44 is bigger than 33. So I would descend to the 45. 44 is smaller than 45, so it would be inserted currently with my current implementation here, to the left of 45. Is this a valid binary search tree? So all elements here are bigger than 33. All elements here are smaller than 45. I wonder if this will just work. I mean, I'm probably missing something, and I'll have an example here in the test cases that will break it, but I'm just gonna go with this, like without inserting between nodes right now, to see if it's possible to work. because as you probably guessed, I don't do much binary search tree implementations daily. So I have these insertions, and if I'm not inserting, then basically I'm moving one to the left. So this covers the case where left node is no and it's larger. So if I just say if node vow is larger than to insert vow, I'm guaranteed that it's not no here anymore. Then I'm gonna say insert into BST node dot. I have to go to the left, right? Yeah, I have to go to the left and to insert. I just pass it along. Else, they should never be equal, so I'm actually just gonna say else, since I'm guaranteed by the definition of the exam that I don't have equal elements. So else I'll just say insert into BST node right and to insert. And again, node right is not no because I have it checked here. So I think this works, but there might be something that breaks it that I didn't think about. So I'm gonna run the test cases. So insert into BST node and to insert, not to insert. I guess I can just pass root here. I actually don't need to have a separate node, and I just return root. So they're probably nicer implementations, but I think this is good enough. If it works, I'll explain it. If it doesn't, then I'll think a little bit more about it. Finished. Is this like good? Your input, your answer, expected answer. 427135, 427135. Show diff. There is no diff. Okay, good. Yay. Huh, I expected this to be harder. I've literally never inserted a node into a binary search tree. I mean, it sounds like it should be something simple, but okay, so this is basically what we did there. Why did I delete my comments? Oh well, whatever. Let's just check the discussion to see how others have implemented it. Java, beats something, Scala, whatever. Question on vow immutability. Poor Scala persons. So they're doing a BFS. While they're using basically an array list of 3 nodes as some sort of a weird queue. I guess he has a bunch of solutions. Is there some like very weird solution? JavaScript one-line solution. Damn. So please, if we ever work together, if you are watching this video and we're working together, never do this. Please, never do this. This is a nightmare to read. I'm not even gonna bother. I mean, there are one-liners that are useful, and then there are one-liners like that. So, iterative and recursive. Yeah, I mean, I guess it's better to write iterative solutions than recursive ones, since recursive solutions can have like a Stack Overflow, too many recursive calls. Usually what I would do is, if the recursive solution is much easier and nicer to write, or if I'm guaranteed that my trees are very small, like let's say I'm parsing Java exceptions and I know for a fact that I pretty much never have a hierarchy of exceptions bigger than a few exceptions, like 10 would be a maximum, and then it's even, I mean, I should never have even 10 exceptions nested. So, well, it might happen, but it's never into the hundreds for sure. So then I'm fine to write recursive functions. Otherwise, I would write a recursive function, then I'll write some test cases, and then I would refactor it into a non-recursive solution, which I think is much nicer. So yeah, there's that. This is all for this video, I guess. I'm not going to implement other solutions since I don't think this is a very interesting problem. What I might do in the future though, since I'm fairly certain that the current format, it might be interesting to see me think about a problem and potentially even be like, oh my god, this guy, how doesn't he know that? Which is nice. I mean, I actually would enjoy if people are feeling motivated by seeing me struggle through some problems. But I think this is not a very good YouTube content. Like, I think people don't come to YouTube to watch like a 15-minute video of somebody struggling with something that's probably like a couple of lines, but he just doesn't know it. So I'm contemplating doing the next week with going into the next week with implementing the solutions first, and then re-implementing them in, again, an unedited video, but knowing kind of what I'm doing instead of just stumbling. But we'll see. For now this is fine, and I mean, I'm happy with what is going on and continuing with the challenge. So having said that, I hope you guys, if anyone sees this, learn something. If you have any questions, I'd love to answer in the comment section. But since we don't have many subscribers, then I mean, especially because we don't have many subscribers, it's really nice because I can communicate with everyone. And yeah, see you tomorrow.